Good day, everyone. We are presenting our project titled Accessible Aeration for Sustainable Water Pretreatment. This project investigates how a simple and low-cost bubble aeration system made from recycled materials can improve the quality of raw lake water before further treatment. This is the group members. Our water sample was collected from Taman Tasik Tunjin Abdullah. The lake receives surface runoff from nearby residential areas and roads, carrying sediments, organic matter, and pollutants. During sampling, the water appeared slightly greenish and turbid, with an initial turbidity of 6.20 NTU, indicating that water quality could be improved before treatment. To solve this problem, we designed a laboratory-scale aeration system using a recycled plastic bottle with an effective water volume of 3.22 liters. The system consists of an aquarium air pump connected to a fine bubble air stone placed at the bottom of the tank. This simple design is affordable, environmentally friendly, and easy to construct. The aeration system works by producing fine bubbles that increase the contact area between air and water. As the bubbles rise, oxygen dissolves into the water while the upward movement creates circulation that reduces stagnant zones and improves oxygen transfer efficiency throughout the tank. First, we measured the initial dissolved oxygen and turbidity of the lake water. Next, the water was aerated continuously for 30 minutes, with readings taken every 5 minutes. After that, the sample was stored for 5 days and a biological oxygen demand, or BOD test, was conducted. Finally, all data were analyzed using Microsoft Excel. The results showed a significant improvement after aeration. Dissolved oxygen increased from 8.15 milligrams per liter to 11.06 milligrams per liter, representing a 35.7% increase. At the same time, turbidity decreased from 6.20 NTU to 4.00 NTU, a reduction of 35.5%. These findings show that aeration effectively improves the physical quality of the water. The dissolved oxygen graph shows that the largest improvement occurred within the first 10 to 15 minutes of aeration. After that, the increase became much slower because the water was approaching oxygen saturation. Therefore, operating the system for about 10 to 15 minutes provides the best balance between oxygen transfer and energy consumption. After 5 days, the dissolved oxygen dropped to approximately 8.07 milligrams per liter. Because microorganisms continued consuming oxygen, the BOD values ranged from 0.88 to 2.99 milligrams per liter. This demonstrates that aeration increases dissolved oxygen immediately, but does not remove biodegradable organic matter. Therefore, aeration should be used as a pre-treatment process rather than a complete water treatment method. This project supports Sustainable Development Goal 6, which promotes clean water and sanitation. By using recycled materials and low-cost components, our design demonstrates that effective water pretreatment can be achieved sustainably and can be adapted for larger-scale applications. Maintaining lake water quality is important for both the environment and the surrounding community. Besides aeration, sustainable lake management also requires proper waste disposal, regular water quality monitoring, and controlling polluted runoff to protect aquatic ecosystems and public health. Although our aeration system successfully improved dissolved oxygen and reduced turbidity, it does not remove microbiological contaminants, heavy metals, or chemical pollutants. Therefore, the treated water is not safe for drinking. Engineers have the responsibility to clearly communicate these limitations and ensure safe and ethical engineering practices. In conclusion, our laboratory-scale bubble aeration system successfully improves dissolved oxygen and reduced turbidity using a simple, affordable, and recycled design. While aeration is effective as a pre-treatment process, additional treatment is still required to remove organic and biological pollutants. This project demonstrates how sustainable engineering can contribute to improving water quality and supporting SDG 6.